Welcome back to Sleepy Science Facts, where even the shiniest mysteries of our world are explored in the calmest way possible. Tonight, we're drifting into the glowing story of gold, a metal so ancient and rare that its atoms were born in the hearts of exploding stars. In this gentle journey, you'll learn how gold is formed, why it's so treasured, and a soothing facts about its quiet journey from stardust to the jewelry and technology we use today. So relax your mind, settle into a cozy spot, and let the soft shimmer of science guide you. Make sure to like, subscribe, and hit the bell for more sleepy science facts. And remember, read the first command for support. It begins with a shimmer. A fleck of sunlight bouncing off a riverbed, a glint buried deep beneath ancient mountains, a whisper of brilliance that has followed humanity since the dawn of time. Gold. The metal that shaped empires, ignited wars, toppled kings, and rewrote the fate of civilizations. A metal so unreactive it refuses to rust, so rare it hides from the world, and so hypnotically beautiful that humans have chased it across deserts, across oceans, across entire lifetimes. This is not just a story about a metal. It is the story of human longing, of ambition, of science, of greed, of brilliance, of discovery. Gold lives inside our myths, our religions, our currencies, our technology, even inside our bodies. And yet, for all its magnificence, gold was born in violence, created not on Earth, but in the heart of dying stars. Gold is older than the sun, older than our planet, older than every ocean and every mountain. Every ring, every coin, every necklace, every buried treasure contains atoms forged in cosmic collisions so catastrophic they shook the structure of space-time itself. Imagine that. The gold you wear, the gold you touch, began as a star's final breath. This documentary is a journey from the beginning of the universe to the deepest mines beneath our feet. A journey through human history, through science, through stories of obsession and triumph. A journey into the quiet, almost mystical power a simple metal holds over 8 billion hearts today. Gold is beautiful, yes. Rare, yes. Valuable, yes. But gold is more than that. It is emotional. It is symbolic. It is a mirror that reflects what we aspire to become: pure, incorruptible, eternal. Yet the pursuit of gold has destroyed lives, poisoned rivers, moved armies. Kings have murdered for it. Explorers have perished for it. And ordinary people like you and me, have gambled everything for one final chance at striking gold. Gold has always been there, whispering across the centuries. "Find me!" And we listened. We always listened. From the ancient Egyptians who believed gold was the flesh of the gods, to medieval alchemists who devoted their lives to creating it, to the prospectors of California who crossed entire continents with nothing but hope in their pockets. Even today, in a world of supercomputers and artificial intelligence, gold remains the backbone of our global economy. Nations hoard it. Investors worship it. Scientists rely on it. Because gold is more than wealth. It is stability in a world of uncertainty. But where does this obsession come from? Why do humans adore gold? Why does it command emotional reverence unlike any other metal? And what forces created gold in the first place? To understand gold, we must dissect it scientifically, from the quantum structure of its electrons to the astronomical chaos that forged its atoms. To understand gold, we must dig through the earth, through mines that plunge miles underground, through geology written in pressure and heat. To understand gold, we must unravel the tales of empires born from its sparkle and shattered by its temptation. This is the story of gold, the element that shaped our world, that built civilizations, that survives longer than any human dream, that defies decay, defies time, defies death. A metal that does not corrode, does not tarnish, does not fade, does not surrender. Gold is eternal. And in the next 2 hours, we will travel through its entire existence, from its birth in the heart of exploding stars to its presence in your jewelry box, your smartphone, your bloodstream. Gold is not what you think. It is deeper, older, stranger, more astonishing than any myth ever told about it. It is cosmic dust that found its way into human hands, and those hands shaped the world in its image. So take a breath. Slow down. Let the shimmer pull you in. Because what you're about to hear is not just science. It is not just history. It is human. It is emotional. It is the story of desire, of survival, of ambition, of the timeless chase for something that never corrodes even when we do. This is gold. The cosmic birth of gold. Gold is timeless. But to comprehend just how timeless it truly is, we must go back not 1,000 years, not 1,000,000, but billions. Before Earth existed, before the sun existed, before the solar system had even taken shape. Our journey begins in the early universe, a fraction of a second after the Big Bang, when reality itself was still molten. In that newborn universe, only the simplest atoms emerged. Hydrogen, helium, a whisper of lithium, nothing more. The universe at that time was like a child, too young, too chaotic, too violent to build anything more complex. Gold was impossible. Gold needed more energy, more gravity, more destruction, more time. The first stars, massive beyond imagination, became furnaces of creation. Inside them, nuclear fusion roared, atoms slamming together, forging heavier elements. Carbon, oxygen, silicon, iron. These stars were the architects of the early periodic table. But even they, with all their fire and fury, could not create gold. Because gold requires an environment where physics goes wild, where atomic nuclei are bombarded with neutrons faster than they can decay, a process known as the rapid neutron capture process, or the R process. The R process is rare. It only occurs in places where nature becomes extreme, places where the rules bend, where matter is torn apart and smashed back together with unimaginable force. One such place, a dying star. When a massive star collapses, it triggers a supernova, a cosmic explosion so brilliant it outshines entire galaxies. In those violent moments, heavier elements surge into existence. For decades, scientists believed supernovae were the primary birthplace of gold. They were partly right, but not fully. Gold needed something even more dramatic. It wasn't until 2017 that the truth was confirmed. On August 17, gravitational wave detectors LIGO and Virgo registered a ripple in space-time. A ripple created by the collision of two neutron stars, the ultra-dense remnants of dead stars. These stars, each only about 20 kilometers across, but containing more mass than the sun, spiraled into each other with unimaginable force. When they merged, they created a kilonova, an explosion 1,000 times brighter than a standard supernova. In that celestial inferno, astronomers detected the unmistakable fingerprints of the R process. Gold was being created, tons and tons of it, scattered across space like glitter from a divine hand. That neutron star collision forged an amount of gold equivalent to several Earths. It launched that gold into the cosmos, a cloud of newborn atoms drifting through interstellar space for billions of years, until the universe cooled enough for them to settle, to drift, to gather. Some of those atoms traveled for eons, carried by galactic winds, caught in the spiraling arms of the Milky Way, eventually finding their way into the nebula that would become our solar system. Think about that for a moment. The gold in your ring, the gold inside your computer, the gold buried in vaults beneath national banks. All of it, every atom, came from the death of stars. You are wearing ancient stardust. You are holding cosmic violence in the palm of your hand. It took billions of years for those gold atoms to settle on Earth, but they didn't settle evenly. Early Earth was molten. Any gold that existed near the surface was drawn deep into the core, swallowed by an ocean of liquid metal. If things had stayed that way, Earth's crust would have almost no gold at all. But something changed the story. During the late heavy bombardment, Earth, young, hot, and chaotic, was pummeled by asteroids. These asteroids carried gold. And unlike Earth, they had no molten core to steal it away. As they crashed, they delivered gold into the crust where humans could someday find it. Without those asteroid impacts, there would be no gold mines, no jewelry, no coins, no empires built on gold. Gold owes its presence on Earth not only to dying stars, but to cosmic collisions that delivered it here, scattering it across mountains, rivers, deserts, and oceans. But even then, gold remained hidden. It took millions of years of tectonic activity, continents cracking, mountains rising, volcanic veins cooling, to trap gold in quartz veins, to fold it into bedrock, to weather it into riverbeds. Gold waited patiently, for millions of years untouched, silent, buried, until one day a human found it. But long before that moment, long before the first prospector panned a river or the first ancient king held a golden crown, gold existed simply as nature's masterpiece, pure, incorruptible, chemically unique. Unlike iron, gold does not rust. Unlike copper, gold does not tarnish. Unlike silver, gold does not react with air. It is the quiet, eternal element immune to decay. And that immortality is precisely why humans fell in love with it. In ancient times, everything decayed: food spoiled, iron rusted, copper corroded, wood rotted, stone cracked. The world changed constantly. Everything died, everything but gold. Gold seemed eternal, and to ancient eyes, anything eternal was divine. When the Egyptians looked at gold, untouched by time, they believed it was the flesh of the gods. When the Inca looked at gold, shimmering like sunlight, they believed it was the sweat of the sun. Across cultures, across epochs, gold symbolized purity, eternity, perfection, not because humans decided it should, but because nature crafted it that way. And even though we now understand gold scientifically, even though we know it is simply a metal with 79 protons, even though we can map its atomic structure, measure its density, calculate its conductivity, the emotional power of gold remains. There is something ancient encoded in us, something almost instinctive that responds to gold. We see it and something stirs, something primal, something inherited from ancestors who lived and died believing that gold was sacred. Even now, in a world of satellites and skyscrapers, gold remains the standard of wealth, the foundation of national reserves, the metal that investors flee to when markets collapse. Gold is stability in a world built on uncertainty. What began as stardust became the backbone of civilization. But to understand how gold shaped our world, how it became the metal of kings and the engine of empires, we must travel from cosmic history to human history. Because once gold touched human hands, everything changed. The first human encounters with gold entered human history quietly, long before writing, long before cities, long before agriculture reshaped our destiny. Imagine the world tens of thousands of years ago, forests untouched by axes, rivers unpolluted, skies unscarred by smoke. In this world of raw nature, the earliest humans wandered as hunter-gatherers. They knew nothing of metals, nothing of smelting, nothing of mining. Their world was bone, wood, stone, and fire. And yet, even then, gold caught their eye. Anthropologists believe some of the oldest human encounters with gold occurred not because ancient people sought it, but because it appeared before them naturally. Gold does not rust or fade, so when a river erodes mountains and carries particles downstream, those particles shine, bright and soft, catching the sun like flakes of captured daylight. Picture a hunter bending to drink from a river, noticing something unusual, a gleam beneath the water, something too bright, too warm, too beautiful to ignore. It is not hard to imagine the moment human fascination began, not as a calculation of value, but as a feeling, a spark of curiosity, a sense that this metal was different from all others. Gold is rare, so not every human group encountered it, but those who did likely treated it as a curiosity at first, a strange, beautiful stone, something to keep, something to treasure, something to hold on to even when food was scarce and mobility was crucial for survival. The earliest pieces of gold ever found by archaeologists date back more than 6,000 years, discovered in the Varna necropolis in modern-day Bulgaria. These burials, older than the Egyptian pyramids and older even than Mesopotamian writing, contain the world's earliest known evidence of processed gold objects. Simple beads, a necklace, a decorative plate, but their meaning is profound. These artifacts show that humans were not merely surviving. They were beginning to express identity, hierarchy, and spirituality. Gold became a marker of status long before the written word. The Varna culture used gold in ways that imply an emerging class system. People buried with gold were likely leaders, spiritual figures, or individuals whose power shaped their small communities. This was the first step in a long, complex relationship between gold and social hierarchy. Because gold, unlike food or tools, is useless for survival in a practical sense. You cannot eat it. You cannot hunt with it. You cannot build shelter with it. And yet gold became the object humans chose to represent power, rank, and meaning. That decision would echo through all of human history. As agriculture emerged and villages transformed into cities, gold's importance grew. The first true civilizations, Mesopotamia, Egypt, the Indus Valley, China, all discovered gold in their own way, and remarkably, all assigned it symbolic significance. There is something universal in human psychology that responds to gold. Its color resembles the sun, the giver of life. Its permanence suggests eternity, and its softness makes it easy to shape, even with primitive tools. In ancient Egypt, gold took on spiritual meaning unlike anything before. The Egyptians believed their god's flesh was made of gold, that the sun god Ra created light from pure golden essence. When pharaohs were buried, their sarcophagi gleamed with gold not for show, but to ensure their safe passage into the afterlife. To the Egyptians, gold was not wealth, it was divinity. It was the material of the heavens, a piece of eternity brought down to earth. One of the most iconic examples is the burial mask of Tutankhamun, a masterpiece of art and metallurgy. Crafted from more than 10 kilograms of pure gold, the mask was designed to preserve the king's soul forever, its radiant surface meant to reflect the eternal sunlight of the gods. While Egypt revered gold spiritually, Mesopotamia, the birthplace of writing, laws, and organized trade, gave gold economic meaning. The Sumerians, Akkadians, and Babylonians used gold to store wealth, to decorate temples, to adorn rulers, and to symbolize divine favor. They built economies on barley, but they built legitimacy on gold. Clay tablets from ancient Sumer mention gold frequently, usually in temples or in the hands of kings. To common people, gold was unattainable. To rulers, it was a mark of absolute power. In the Indus Valley civilization, spanning modern-day Pakistan and northwest India, gold jewelry flourished. Beads, bangles, and ornaments show remarkable craftsmanship for their age, some so precise that modern jewelers still admire their symmetry. Evidence suggests Indus gold came from the mountains to the north, likely Afghanistan, transported by early traders. Already, thousands of years ago, humans were transporting gold across vast distances, and wherever gold went, culture followed. In China, gold appeared somewhat later but quickly gained ceremonial prominence. Chinese dynasties valued jade above all, but gold was associated with authority, used in crowns, coins, seals, and royal adornments. The earliest Chinese coins, the Ying Yuan, were made of gold sheets, a precursor to standardized currency systems. While each early civilization discovered gold independently, they all reached the same conclusion. Gold was not simply beautiful, it was meaningful. It represented something more than material, something emotional, something eternal. But why gold and not another metal? Why not silver, copper, or bronze? The answer lies in chemistry. Gold is one of the least reactive elements in the universe. It resists oxygen, moisture, sulfur, and almost all natural corrosive forces. Ancient people could find it in pure nuggets untouched by time. Copper tarnishes, silver darkens, iron rusts. Gold does nothing. It remains flawless, as if immune to the world's decay. In a world where everything rotted, eroded, cracked, or broke, gold never changed. This permanence created a psychological phenomenon. Humans associated gold with immortality. The earliest myths echo this. In Sumerian legends, gods wore gold as symbols of their eternal life. In Egyptian mythology, consuming gold brought closeness to divinity. In ancient China, alchemists sought elixirs of immortality, many of which used powdered gold. But gold's survival through time also made it reliable. In trading societies where trust was fragile and writing rare, a stable, unchanging material became a foundation for exchange. By 1500 BCE, Egypt had established the first known gold standard, a unit of weight called the deben, used for everything from grain to cattle to land. This was the beginning of gold's journey into economics. But while gold appeared divine, obtaining it was anything but. Ancient gold mining was brutal. Early miners worked with simple tools, stone hammers, wooden wedges, fire-setting techniques that cracked rock by heating it, then cooling it rapidly with water. Entire mountainsides were chiseled away by hand. In Nubia, south of Egypt, mining camps stretched for hundreds of kilometers. Slaves and prisoners dug through scorching desert heat, crawling into narrow tunnels lit only by oil lamps. Many never returned. Gold was precious because it demanded sacrifices. The earth did not give it freely. And the more civilizations valued gold, the more they demanded it. Trade routes formed. Caravans crossed deserts. Ships sailed across seas. Gold moved from civilization to civilization, binding them together in early global networks. The ancient Mediterranean saw gold from Egypt traded to Greece, gold from Anatolia traded to Mesopotamia, gold from the Caucasus traded to Persia. Over time, gold became not just a symbol of a ruler's power, but a tool for diplomacy, tribute, and war. By the time of the Persian Empire, gold was used to pay soldiers, fund roads, and maintain one of the largest armies the world had ever seen. The Greeks expanded this relationship even further. They admired gold's beauty, but valued its utility. Gold coins, staters, darics, and later drachmas became standardized monetary units, exchanged across entire regions. The Greeks were among the first to recognize that gold's stability made it ideal for currency. Meanwhile, in the Americas, far across the ocean, entirely separate civilizations discovered gold in their own ways. The ancient peoples of Peru, Colombia, and Mexico crafted extraordinary gold artifacts. The Moche created lifelike golden masks. The Chavin made intricate ornaments. The Inca, like Egypt, saw gold as sacred, the sweat of the sun. They adorned temples with sheets of pure gold. Their greatest shrine, the Temple of the Sun in Cusco, reportedly shimmered so brightly it stunned visitors. And yet, in these civilizations, gold was not money. It was spiritual, artistic, symbolic. They did not hoard it for wealth, but shaped it into beauty and devotion. This would change violently when European explorers arrived. But before the age of conquest, before gold became the engine of empire, gold lived in harmony with belief. For thousands of years, gold was not about greed. It was about meaning. Even in the Bible and Quran, gold is a symbol of purity, paradise, and divine light. Across cultures separated by oceans and millennia, gold meant the same thing: something holy, something eternal, something worthy of reverence. But as human societies grew, as trade expanded, as empires formed, gold shifted roles. It transformed from a sacred material into something far more worldly, a tool of power, politics, and economics. This shift marked a turning point in history. The spiritual metal of the ancient world became the currency of kings. And once gold became currency, the desire for it intensified. Wars began. Empires rose. Empires fell. Gold drove exploration, colonization, and exploitation. It was no longer just a symbol. It was fuel. It was leverage. It was control. The next era of gold would be darker, brighter, grander, and far more brutal. But to understand that transformation, we must move from ancient civilizations into the dawn of empires, when gold became not just divine, but strategic. Not just admired, but demanded. Not just revered, but pursued across continents. The world was about to change forever, and gold would be at the center of that transformation. Gold and the rise of empires. Gold has always moved in one direction, toward power. And as humanity stepped into the age of empires, gold became not only a symbol of authority, but the very engine that powered armies, infrastructure, politics, and ambition. In this chapter, the world expands dramatically. Small city-states become nations. Nations become empires. And at the center of this transformation lies a shimmering metal that never rusts, never decays, never bows to time. By the dawn of the first millennium BCE, the world had already seen gold used in temples, crowns, and sacred objects. But something new was happening. Civilizations were growing in scale. Population was increasing. Trade networks were stretching farther. Ambition was rising. And gold, for the first time in history, became the lifeblood of geopolitics. One of the earliest empires to truly understand the strategic power of gold was the Kingdom of Lydia in Asia Minor. Around 600 BCE, something revolutionary occurred in its capital, Sardis, the invention of the first gold coin. King Croesus, whose name would become a synonym for extreme wealth, standardized gold and silver coins called staters. These coins did something extraordinary. They made wealth portable, measurable, and most importantly, trustworthy. Until this moment, trade relied on bartering or weighing metal fragments of uncertain purity. Croesus changed that. His coins had standardized weight and guaranteed purity, stamped with the royal seal. For the first time, a piece of gold was not just a metal, but a promise, a guarantee backed by the king himself. This simple innovation launched a monetary revolution. Trade flourished. Markets expanded. Soldiers could be paid reliably. And Lydia's economy surged. When the Persian Empire conquered Lydia, they adopted Croesus's coinage system instantly. The Persians understood its value. Under Darius the Great, they introduced the gold daric, one of the most influential coins in ancient history. With the daric, the Persians paid their armies, funded massive construction projects, and maintained control over one of the largest empires the world had ever seen. The daric was so stable and so widely respected that Greek historians called it the archer, after the figure stamped on its face, but also because the daric silently conquered territories where Persian armies could not reach. With the rise of coinage, gold became more than a royal treasure. It became a system through which empires could enforce economic and political order. But even with standardized currency, gold remained rare. Empires needed access to gold mines to sustain their power. This need for supply shaped geopolitics. Whoever controlled the mines controlled the money, and whoever controlled the money controlled everything else. When Alexander the Great embarked on his legendary conquests, gold was both his motive and his method. He inherited a Macedonian kingdom rich in silver and gold mines, especially from Mount Pangaean. These mines funded his early campaigns. But it was the Persian treasury, overflowing with centuries of accumulated darics, that transformed Alexander's forces into an unstoppable machine. When he captured Susa, Persepolis, and Babylon, he seized tens of thousands of tons of gold and silver. This influx of wealth was so vast that it destabilized the Persian economy for generations. Alexander did not merely conquer Persia, he drained its economic lifeblood. With gold in his possession, he paid his soldiers, financed new cities, built roads, and spread Greek culture across 3 continents. Gold became a tool of cultural transformation. Wherever Alexander went, Greek coins followed. Whatever language people spoke, whatever gods they worshipped, the image of Greek rulers stamped on gold coins spread the message of power more elegantly than any speech. When Alexander died, his generals divided his empire, but the gold he redistributed continued influencing trade long after the political boundaries dissolved. Meanwhile, in the Mediterranean, another power was rising: Rome. Rome's relationship with gold was complex. shaped by conquest, engineering, taxation, and ruthless determination. In its early days, Rome relied more on bronze than gold. But as the Republic expanded, it encountered gold-rich territories that reshaped its economy. The conquest of Gaul under Julius Caesar became one of Rome's most significant gold acquisitions. Caesar returned from Gaul with enormous quantities of gold, enough to pay soldiers, cancel debts, and build political capital that propelled him to dictatorship. Caesar's gold changed Rome forever. It centralized power, shifted the balance of political factions, and allowed Rome to transition from a republic into an empire. Under Emperor Augustus, Rome established some of the most advanced mining operations in the ancient world. Las Medulas in Spain, for example, became a marvel of engineering. Roman engineers used a technique called ruinamontium, or wrecking the mountains, where they diverted entire rivers into underground tunnels carved into mountainsides. The water pressure collapsed the rock, exposing gold deposits. Thousands of slaves extracted gold from the ruins. The site became so massive that modern satellite images reveal scars on the landscape still visible 2,000 years later. But Rome depended on gold for more than currency. Gold fueled the Roman military. Gold lubricated politics. Gold held the empire together. Gold coins traveled across Europe, Africa, and Asia, facilitating trade from Britain to India. A Roman merchant in Egypt could buy spices from Arabia, pay in gold ore, and know they would be accepted anywhere along the Silk Road. Even when Rome began to falter, gold remained stable. As the empire crumbled from internal corruption and external invasion, gold coins were hoarded, hidden, buried, preserved as symbols of a world that once promised order. When Rome finally fell, its gold did not vanish, it simply moved. Much of it flowed eastward into the Byzantine Empire, where gold became the backbone of one of the most resilient currencies ever created, the solidus, later known as the bezant. The Byzantine solidus was so pure and reliable that it dominated global trade for nearly 700 years. No other currency in history has matched such longevity. And once again, gold was the reason why. While Europe entered the early Middle Ages, gold grew scarce. Political fragmentation made mining difficult. Chaos restricted trade routes. Wars made transportation dangerous. As a result, gold became even more precious. European kings and nobles hoarded what little remained, locking it inside treasuries and church vaults. In these centuries, the Catholic Church became one of the largest accumulators of gold in the world. Gold chalices, gold reliquaries, gold altars, all served religious function, but also represented authority in an unstable world. Gold was not merely wealth, it was legitimacy. But while Europe struggled, gold was flowing freely in Africa. Kingdoms such as Mali, Ghana, and Songhai thrived on gold-rich lands. West African miners extracted gold from riverbeds and shallow pits, transporting it across the Sahara via camel caravans. These caravans, stretching for kilometers, carried salt, spices, ivory, and above all, gold. This gold made West Africa legendary. When Mansa Musa, the emperor of Mali, undertook his pilgrimage to Mecca in 1324, he brought so much gold that the economies of Cairo, Medina, and Mecca collapsed temporarily. Historians estimate he distributed so much gold in gifts and trade that it caused inflation across North Africa for 12 years. Mansa Musa's journey remains one of the most dramatic examples of gold's power to disrupt economies. And yet, he also used that wealth to build centers of learning, libraries, and mosques. Gold shaped culture as much as it shaped economy. Meanwhile, in the Islamic Golden Age, gold coins called dinars circulated from Spain to India, serving as stable currency for centuries. Gold linked continents that rarely met face to face. It was a universal language even before the modern idea of currency took shape. While the old world perfected trade, the new world shimmered with its own golden empires. The Aztecs, Maya, and Inca all used gold not as money, but as spiritual expression. The Inca covered temples with gold sheets, so thin and perfect that Spanish conquistadors later marveled at their craftsmanship. The Temple of the Sun in Cusco reportedly reflected light so brilliantly that it could be seen from miles away. But this golden world would soon collide with another, a collision that would change global economics forever. When Europeans arrived in the Americas, they discovered civilizations overflowing with gold. To the Spanish, who had exhausted their own minds, this discovery was irresistible. Gold became the justification for conquest, the fuel for colonization, and the treasure that would reshape the world economy. The Spanish plundered temples, melted artifacts, enslaved miners, and transported massive quantities of American gold back to Europe. This influx transformed Europe into a global financial powerhouse. But it also caused inflation, destabilized economies, and sparked rivalries between emerging European states. Gold both empowered and distorted. It built naval fleets, funded wars, enriched monarchies, and accelerated the rise of capitalism. But it also left scars, deep, painful scars across indigenous populations whose cultures were stripped of their heritage. This era, brilliant and brutal, marked the moment gold became a global force. Empires rose on gold. Empires fell without it. And the pursuit of gold drove exploration across oceans, deserts, and mountains. It would inspire future ages of madness and speculation, including the legendary gold rushes of the 19th century. The world was changing. Technology was improving. Populations were expanding. Borders were shifting. Yet one constant remained: the human hunger for gold. It is a hunger born not just of greed, but of fascination. A hunger rooted in deep psychology, ancient symbolism, and the undeniable influence of a metal that refuses to decay. Gold was no longer simply a treasure. It had become a catalyst, a force, a destiny. But its story was far from over. Because the next era of gold would be the most explosive yet, an era defined not by empires, but by ordinary people risking everything for a chance to find a shimmer in the earth. The world was on the brink of gold fever, and nothing would ever be the same again. The blood of stars gold is a paradox. It is one of the rarest substances in the universe, yet human civilization has shaped entire epochs around it. It is chemically unreactive, yet it provokes some of the strongest emotions known to our species. It is physically soft, yet has played a hardened role in empire building, exploration, war, and technological progress. And so this chapter begins not on Earth, but in the deep cosmic dark where gold itself was first forged. Because to understand why gold matters so much to us, we must first understand that its story began long before humanity existed. long before Earth existed, long before even the sun first ignited its nuclear flame. Gold is a relic from a time before time, created in one of the most violent, cinematic events the universe has ever known. The collision of neutron stars, the ultra-dense cores left behind after supernovas tear apart massive suns. Imagine a star many times larger than our sun collapsing in on itself, compressing until protons and electrons fuse into neutrons so densely packed that a teaspoon of their matter weighs billions of tons. Now imagine two such objects spiraling around one another, locked in a gravitational dance that takes millions of years. Eventually, they crash. In that instant, less than a second, temperatures soar to unimaginable extremes. Space-time itself trembles. Gouts of matter, raw, neutron-rich debris, are flung out into the cosmos. In that hellish furnace, atoms rapidly absorb neutrons, creating heavier and heavier elements. The process is called rapid neutron capture, or the R process, and it is here that atomic nuclei are hammered into forms that the calmer environments of ordinary stars could never produce. Gold emerges from that chaos, not metaphorically, literally. It is born in an event so powerful, so violent, so extremely rare that only a handful happen in an entire galaxy every million years. But that's enough, because each collision seeds the cosmos with a spray of heavy metals: gold, platinum, uranium, atoms drifting in nebulae, mixing with clouds of hydrogen and helium, eventually condensing into young solar systems. Our solar system began this way, in a swirling disk of dust and gas that carried within it the ancient ejecta of dead stars, which means the gold on your finger, the gold stored in central bank vaults, the gold buried deep in Earth's crust. All of it is older than Earth. It is older than the sun. It is older than the very concept of time as humans understand it. Gold is the universe's memory, frozen in metal. And yet, for billions of years after Earth formed, that gold remained buried, untouched, locked far beneath the surface. It took a series of improbable geological processes to bring it anywhere we could reach. Earth, in its youth, was molten and chaotic. Heavy elements like gold were pulled downward by gravity as the young planet differentiated into a core, mantle, and crust. Most of Earth's gold, an estimated 99.9%, sank into the core, forever inaccessible. The gold we mine today comes from a later gift. During the late heavy bombardment, roughly 4 billion years ago, the young Earth was pummeled by asteroids rich in metals, including gold. Those impacts embedded new veins of gold into the crust, veins that would one day draw humans into mountains, deserts, and entire continents. For millions of years more, gold waited. But eventually, the planet's own restlessness lifted these ancient deposits upward. Volcanic activity fractured the crust. Hot fluids circulated through rock, dissolving trace amounts of gold from deep below and redepositing it into quartz veins. Mountains rose and fell. Rivers carved through stone, carrying flecks of gold into floodplains and valleys. Nature refined it slowly, grinding rocks to dust until the heaviest mineral, gold, accumulated in stream beds and river bends. Long before humans existed, Earth was already shaping gold into something discoverable. But discovery required another ingredient: curiosity. It required a species that would look at a tiny yellow glint and feel something: wonder, desire, fascination. That feeling did not emerge suddenly. At first, Early humans saw gold simply as a strange stone, but its properties marked it as different from anything else they found in the natural world. No matter how long it lay exposed, it did not rust like iron. It did not tarnish like copper. It did not break or fracture. It gleamed eternally. Even before metallurgy developed, gold drew the human eye for one simple reason: sunlight loved it. Hold a nugget of gold in your hand, and you will notice something curious. It does not merely reflect light, it seems to generate a warm internal glow. This optical phenomenon is partly due to the electron configuration of gold atoms, a relativistic effect caused by how electrons close to gold's heavy nucleus move at significant fractions of the speed of light. Those relativistic distortions shift the wavelengths of light, giving gold its unique warm yellow color. Put simply, gold looks like sunlight you can hold. Early humans were mesmerized. Artifacts from Paleolithic sites show that humans were collecting gold at least 40,000 years ago, long before agriculture, long before writing, long before any concept of wealth. They picked it up not because it was useful, but because it was beautiful. And beauty, in every era, has been one of the most powerful forces shaping human culture. Gold soon took on different meanings in different societies. To the ancient Egyptians, gold symbolized the flesh of the gods. Pharaohs were buried in gold masks not simply for status, but because gold was believed to be eternal, just like the divine. The Incas called gold the sweat of the sun. In ancient India, gold was a manifestation of purity and prosperity. In China, it represented luck and spiritual balance. Everywhere, somehow, humans decided the same thing. Gold was not just a metal, it was a symbol, a story, a bridge between the human world and something greater. But why gold? Why not silver? Why not copper? Why not any of the other metals early humans encountered? Scientists have explored this question in surprising detail. Among all elements on the periodic table, only a tiny handful meet the criteria for becoming a global standard of beauty, trade, and symbolic meaning. An ideal metal must be rare but not too rare, durable but workable, stable but visually distinctive. Gold happens to be the single best match. It does not corrode. It is soft enough to be shaped by early tools. It melts at a manageable temperature. It shines unlike any other metal. And unlike elements such as platinum, which are too rare and too difficult to work with, gold exists in just the right quantities to be treasured but accessible. Nature did not design gold for humans, but gold is one of the few elements that feel designed. That illusion is powerful, and for thousands of years, that power shaped history. Our ancestors followed gold across deserts, across oceans, across uncharted continents. Entire civilizations rose on the promise of gold and fell trying to control it. For ancient empires, gold wasn't just wealth. It was the language of diplomacy, the symbol of divine authority, the backbone of military power. When the Lydians invented the world's first standardized gold coins around 600 BCE, they unknowingly set humanity on a path toward globalized economies. When Alexander the Great conquered Persia, he seized its gold reserves and redistributed them to fuel his campaigns. When Rome expanded across Europe, it used gold to pay soldiers, bribe rivals, and stabilize its currency. Every empire understood the same truth. Gold was more than a resource. It was leverage. But as we move deeper into this chapter, a more uncomfortable truth emerges. Our fascination with gold has never been just about beauty or utility. It has often been about greed. By the time Europeans reached the Americas, the hunger for gold had become a driving force behind global exploration. Columbus himself wrote that his objective was gold and whatever else of value. Conquistadors slaughtered civilizations for it. Kings taxed their people for it. Adventurers gambled their lives searching for it in unforgiving lands. And yet every time humanity pursued gold with violence, the metal seemed to reveal a darker capacity, to amplify not just the best in us, but the worst. The 19th century gold rushes transformed entire continents, but also brought exploitation, environmental destruction, and conflict. But these events also reshaped the modern world in ways few people realize. The infrastructure of California, from its railroads to its cities, was built on the foundation of gold. Australia's multicultural identity was born in part from gold rush migration. South Africa's political and economic landscape was shaped by the discovery of gold near Johannesburg. Gold demanded human ambition and shaped humanity in return. But perhaps the most fascinating twist in gold's story occurred when the modern world tried to move beyond it. With the rise of paper money, digital banking, and modern financial systems, governments attempted to detach wealth from physical materials. Yet even when currencies were no longer backed by gold, central banks still clung to it. Even today, the world's largest economies sit on thousands of tons of gold reserves. Why? Because gold is the one form of wealth that has outlasted every government, every economic crisis, every war. It is the only asset that is not someone else's liability. A bond depends on a government's promise. A stock depends on a company's survival. A currency depends on faith, but gold depends only on physics. The atoms in a gold bar will remain gold atoms for billions of years. That, in a world full of uncertainty and chaos, is powerful. But gold's journey is not finished. In the last several decades, gold has entered a new chapter, one rooted not in mythology or empire, but in science and technology. Its extraordinary stability makes it invaluable for electronics. Every smartphone contains gold. Every modern spacecraft relies on it. Gold reflects infrared radiation so efficiently that satellites and telescopes use gold-coated mirrors. Even the visors of astronauts' helmets are lined with a thin layer of gold to protect their eyes from harsh solar radiation. Gold conducts electricity better than copper and resists corrosion far better than silver. In the circuitry of our technologies, in the heartbeat of our digital world, gold quietly keeps everything running. And as we push further into the future, gold may take on roles we have not yet imagined. Quantum computing, biomedical nanotechnology, ultra-stable electronics for interstellar missions. In these cutting-edge fields, gold is uniquely suited to environments where failure is not an option. The same immortality that made ancient civilizations adore gold now makes it scientifically indispensable. But with these advancements comes a new problem: supply. Humanity has mined roughly 200,000 tons of gold in all of history. Most of it still exists, melted and remelted countless times. But the easy deposits, the rivers gleaming with placer gold, the shallow veins in hillsides are almost gone. Modern gold mining relies on massive industrial operations that move mountains for grams. And the environmental toll is steep. Deforestation, toxic runoff, disruptions to ecosystems. As the world pushes deeper into the 21st century, we are faced with a paradox. Gold remains essential, and yet more difficult to justify extracting. This has led researchers to explore sources once considered unimaginable, mining gold from seawater, from asteroid belts, even from neutron star remnants if humanity reaches such heights. Astronomers have identified asteroids so metal-rich that a single one could contain more gold than Earth's entire crust. If future space industries reach them, gold's scarcity and its value could transform dramatically. But scarcity is not what makes gold meaningful. Scarcity is merely the economic side of a deeper truth. Gold matters because humans decided it mattered, and because the universe forged it in a way so rare, so violent, so awe-inspiring that it feels almost mythic. Gold is a storyteller. It carries within it the memory of ancient stars, the imprint of geological forces, the weight of civilizations, the shimmer of ambition, and the promise of futures we have yet to imagine. Standing on a riverbank thousands of years ago, the first human who picked up a gold nugget could not have known any of this. But they would have felt something, a spark of emotion, a connection to something larger than themselves. That feeling echoes across time, in vaults beneath modern cities, in jewelry passed down through generations, in the circuits of satellites orbiting Earth, in the dreams of people who still search rivers for a chance at fortune. Gold's journey is our journey. And its next chapter has already begun. The age of obsession gold has always lived in two worlds at once. In one world, it exists as a scientific marvel, an element forged in the cosmic violence of neutron star collisions, a metal whose atomic stability has defied entropy for billions of years. In the other world, it exists as a mirror held up to human nature, revealing our desires, fears, ambitions, and contradictions. Nowhere is this duality more powerful than in the era historians often call the Age of Obsession, a time when the world no longer simply admired gold, but chased it, worshipped it, built nations around it, and destroyed civilizations for it. To understand this age is to understand something uncomfortable about ourselves, because gold has never truly corrupted humanity. Instead, it has exposed humanity. As the ancient world transitioned into the medieval and early modern eras, gold's value did not diminish, it intensified. Once, gold symbolized the divine. Then it symbolized kingship. But as trade routes expanded and global empires took shape, gold became something even more potent, the raw material of power itself. In the courts of Europe and Asia, where the future of nations could hinge on a king's treasury, gold wasn't just wealth. It was the bloodstream of war, diplomacy, and ambition. Monarchs counted their reserves not simply to gauge prosperity, but to estimate how many armies they could raise, how many ships they could build, how many alliances they could secure. Gold anchored strategy, and strategy shaped history. But this was also the moment when an extraordinary shift occurred, something subtle but monumental. The world realized that gold was finite, limited, scarce, and scarcity breeds obsession. In palaces across Europe, advisors whispered the same warning to kings. Gold reserves are dwindling. Trade deficits are rising. Rivals are growing stronger. If you lose access to gold, you lose everything: your military strength, your political leverage, your international standing. And to those who feared decline, fear has always been more powerful than curiosity. Out of this fear, European powers launched one of the most ambitious and morally complex eras of exploration in human history. The oceans became highways for ambition. Sailors braved storms, scurvy, and unknown waters for one reason: gold. It did not matter if the rumors were exaggerated or impossible. Stories of golden cities, golden temples, golden empires ignited imaginations. In an era without satellites, without maps, without accurate navigation, imagination was its own form of gravity. It pulled explorers west across the Atlantic, south around Africa, east across the Indian Ocean. The world cracked open under the weight of dreams, dreams lined in gold. When Europeans reached the Americas, they encountered civilizations that already possessed vast quantities of the metal. The Aztecs and the Incas did not view gold through the same lens of monetary value. To them, gold was spiritual. It was art. It was ritual. It was cosmic symbolism. But the conquistadors who arrived with steel armor and insatiable hunger saw something very different. They saw a resource, one that could be extracted, melted, transported, and delivered to kings who measured human worth by the amount of gold their ships could carry. The collision between these worldviews was catastrophic. It was one of the darkest chapters in human history. Gold became both the justification and the reward for conquest. And yet, even as empires expanded and plundered, gold remained strangely indifferent. It did not care about borders or beliefs. It did not care whose flag it rested under. Gold is the great paradox, a silent metal that inspires loud actions. And nowhere was that louder than in the 19th century, when humanity entered the most dramatic gold rushes the world had ever seen. The California gold rush of 1848 was not the first gold rush, nor the last, but it became the archetype, an explosion of hope, chaos, desperation, and promise. When gold was discovered at Sutter's Mill, the world was already changing rapidly. Industrialization was accelerating. Railroads were knitting continents together. New technologies allowed news to travel faster than ever before. And so within months, the rumor of gold in California became more than a possibility. It became destiny. Hundreds of thousands of people from every corner of the world dropped their lives and marched toward an unknown future. Some sailed around Cape Horn, a journey of months through deadly storms. Others crossed the malaria-ridden jungles of Panama. Many trekked across the American frontier, facing starvation, harsh winters, and violence. But they kept moving, because the story of gold does not inspire half steps. It inspires leaps of faith. When these dreamers arrived, they found something unexpected. Gold was indeed there, scattered in riverbeds and mountain streams, but nature did not distribute it evenly. For every miner who struck a fortune, hundreds earned nothing. Possibility created inequality, and inequality bred tension. The goldfields became melting pots of nationalities, languages, religions, ambitions, and resentments. In one valley, you might find a runaway slave from Virginia working beside a fisherman from Guangdong. In another, a failed merchant from London digging beside a soldier who deserted the Prussian army. They were equal in one sense. The earth owed them nothing. The Californian landscape, once untouched and ancient, transformed almost overnight. Rivers were diverted. Hillsides were collapsed through hydraulic mining. Forests were cut down to build shacks, sluices, and makeshift towns. Environmental destruction that once took centuries now happened in a single decade. But out of this chaos grew something larger than gold. Cities emerged, San Francisco most famously. Trade exploded. Railroads stretched across the continent. The United States rapidly shifted from a dispersed agrarian society to a nation hurtling toward industrial might. In other words, gold built the foundation for a new world. The same pattern unfolded in Australia, South Africa, and Canada. In Ballarat and Bendigo, entire communities sprang out of dry bushland almost overnight. In the Witwatersrand Basin of South Africa, the discovery of deep gold seams reshaped not only the economy, but the very social structure of the nation, establishing mining empires, migrant labor systems, and economic hierarchies that still influence the region today. In the Klondike, prospectors climbed the icy Chilkoot Pass under brutal conditions, their silhouettes forming dark lines against snow-covered mountains, all for a dream as ephemeral as light on water. Across continents and cultures, gold did what few other forces could. It mobilized humanity on a global scale. It made ordinary men and women brave the unthinkable. It reshaped maps. It overturned traditions. It collapsed societies and built new ones. All of this from a metal that, in practical terms, offered little to survival. You cannot eat gold. You cannot drink it. It cannot shelter you from the cold. And yet, in every corner of the world, people risked their lives to possess something that, scientifically speaking, is one of the least reactive elements on Earth. But this age of obsession revealed a deeper truth. Gold is not valuable because it is rare. It is valuable because humans decided it was worth trading their time, their labor, and their safety for it. Value is not an inherent property of gold. It is a human story, collectively agreed upon. And that collective belief has been strong enough to move armies and shift economies. As industrialization progressed, gold gained a new role, one that would shape modern finance for over a century. It became the backbone of global currency systems. Under the gold standard, a country's money was directly linked to its gold reserves. Suddenly, gold was not just a symbol of wealth, it was wealth. Governments stored it in vaults. Banks issued notes backed by it. International trade depended on it. Stability depended on it. For a time, the world seemed anchored to something solid, something eternal. But no anchor is perfect. The 20th century brought wars so large, so devastating, that no amount of gold could stabilize the economies that emerged from their ashes. Governments printed money far beyond what their gold reserves could justify. Nations faced impossible choices: preserve the gold standard and let economies collapse, or abandon it and reshape the financial world. Eventually, they chose the latter. One by one, countries severed their currencies from gold. By the 1970s, the last major link was gone. And yet, this is the twist: gold did not lose its power. If anything, it grew stronger. Because when trust in institutions falters, people return to what they consider eternal. In times of peace, gold is a luxury. In times of uncertainty, it becomes a lifeline. When inflation rises, gold rises. When markets crash, gold rises. When governments fall, gold rises. When fear spreads, gold shines brightest. It is the metal of last resort, but also the metal of first instinct, a paradox that reveals everything about human psychology. This brings us to the most fascinating part of the modern age: the fact that gold is no longer merely mined or minted. It is engineered. Scientists now manipulate gold at the nanoscale, creating particles so small they are invisible, yet capable of curing diseases, enabling medical diagnostics, improving electronics, and enhancing materials. The metal that once adorned pharaohs now helps fight cancer. It forms conductive pathways in microchips. It coats spacecraft instruments. It stabilizes chemical reactions. The age of obsession has become the age of innovation, but obsession has not disappeared. Gold markets remain some of the most emotionally charged in the financial world. Investors panic buy during crises. Governments accumulate reserves quietly. Smugglers move gold across borders in hidden compartments. Ordinary people, fearing economic instability, convert savings into jewelry. The same forces that drove ancient civilizations still echo today, because gold is not just matter, it is meaning. And meaning, unlike metal, does not tarnish. Humanity's relationship with gold is far from over. If anything, it is evolving into something even more complex. Because as the world pushes into new frontiers, digital currencies, artificial intelligence, space exploration, gold stands at a crossroads. Will it remain the backbone of trust, or will it become merely one precious metal among many? The truth is, the future of gold depends on the same force that has shaped its past: human belief. But to understand where that belief is heading, we must step into another chapter entirely, one where gold leaves the earth itself. The cosmic future of gold. For thousands of years, humanity believed that gold existed only in the ground beneath our feet, hidden in mountains, buried in riverbeds, trapped in ancient volcanic veins. But today, as we stand at the threshold of a new age, a startling truth has begun to emerge. Earth is not the final chapter in gold's story. It is merely one chapter in a cosmic narrative still unfolding. In this new age, gold is no longer just a physical resource. It is a bridge between our past and our future, between the planet that shaped us and the universe that awaits us. The ground beneath us may be nearly exhausted, but the sky above us is limitless. When astronomers first discovered that asteroids contain metals in concentrations far beyond anything found on Earth, it sent shockwaves through scientific and economic communities. One asteroid, just one, could contain more gold than all humanity has ever mined. Not metaphorically, literally. The asteroid 16 Psyche, a massive metallic world orbiting between Mars and Jupiter, is believed to contain iron, nickel, and precious metals, including gold, in quantities so vast they defy imagination. If humans ever managed to mine even a fraction of Psyche, gold would no longer be a rare metal. It would become abundant, so abundant that it could crash global markets, rewrite economies, and reshape the concept of value itself. But before that even becomes possible, space agencies and private companies are already preparing for the early steps of off-world mining. NASA's Psyche mission aims not to extract metals, but to study the asteroid up close. Its importance is symbolic. For the first time in human history, we are sending a spacecraft not to explore landscapes or search for life, but to examine a planetary body made largely of metal. And gold is part of that story. Meanwhile, private companies such as Planetary Resources and Deep Space Industries once dreamed of mapping asteroid belts for mining targets. Their early efforts faltered, but their ideas did not die. They merely evolved. Today, countries like China, Japan, and Luxembourg have created legal frameworks enabling future space mining operations. Billionaires invest in aerospace ventures not only for exploration, but for the long-term possibility of harvesting the metals locked in the asteroid belt. But if gold becomes an extraterrestrial resource, its meaning on Earth may change forever. Because value is not just supply and demand. Value is emotion. Gold has power because it feels rare, ancient, sacred. What happens when we find out that the universe is full of it? Will gold lose its magic? Or will we find new magic in the act of reaching it? Mining gold in space is not just a technological problem, it is also a philosophical one. Consider the challenges involved. To reach an asteroid, a spacecraft must travel millions of kilometers. It must anchor itself to a body with almost no gravity, extract materials in a vacuum, process ores without atmosphere or water, and transport refined metals back to Earth without burning them up during re-entry. Every step requires technologies we are only beginning to imagine, and yet the potential reward is staggering. A single successful expedition could yield trillions of dollars in metals. Entire industries, robotics, automation, aerospace engineering, would be transformed. Energy demands would surge, driving the development of next-generation nuclear propulsion systems. Spaceports would multiply. Trade routes would expand beyond Earth. Humanity's first gold rush happened on Earth's rivers. The next gold rush may happen among the stars. But gold's future is not only about space. It is also about the deep, hidden corners of our own planet. Scientists now believe that more than 99% of Earth's gold lies trapped in the core, unreachable by any technology we possess. Even so, mysteries remain. Research has uncovered exotic microbes, tiny organisms living in harsh environments that can precipitate gold out of solution, forming microscopic grains. Some bacteria actually feed on gold compounds, creating pure metallic gold as a waste product. Imagine that, life forms that literally excrete gold. It sounds like mythology, yet it is real biology. These microbes do not produce enough gold to fuel economies, but they reveal something profound about nature. Gold is not just a geological material. It is part of Earth's living ecosystem. Another frontier is nanogold, gold engineered at the molecular level. At this scale, gold behaves nothing like the metal we know. It becomes reactive. It changes color. It forms structures that interact with light and electricity in ways that defy normal rules. These properties have already led to breakthroughs in medicine. Gold nanoparticles can target tumors, deliver drugs directly to cancer cells, and destroy harmful pathogens with astonishing precision. In diagnostics, gold-based tests can detect diseases at earlier stages than ever before. In chemistry, nanogold catalyzes reactions essential for green energy, clean manufacturing, and advanced materials. And in electronics, ultra-thin layers of gold enable components so tiny they approach the limits of physical possibility. In other words, gold is no longer simply mined. It is engineered at the scale of atoms. But the most surprising frontier of all may be that gold could one day serve as humanity's shield against the dangers of space. Because gold reflects radiation better than almost any metal, future spacecraft may use gold-coated materials to protect astronauts during long-duration missions. Solar storms, cosmic rays, and high-energy particles pose deadly risks to human explorers. Gold may be the key to shielding them. Already, the visors on space helmets use gold to filter harmful radiation. As missions extend to Mars, asteroids, and beyond, gold's role will only increase. But the farther we push into the universe, the more we confront a strange irony. Gold is a cosmic element, yet we spend so much of our history fighting over the small amount on Earth. The stars produced unimaginable quantities of gold over billions of years, yet only a tiny fraction ever reached our planet. For most of human history, it was enough to spark wars, fuel empires, and inspire dreams. But as humanity grows more technologically advanced, we may outgrow the planet-bound perspective that defined past centuries. We may reach a point where gold stops representing scarcity and starts representing possibility. What happens when gold is no longer rare? What happens when the heavens become the new mines? Some economists argue that an influx of cosmic gold would collapse its value, destabilizing markets and forcing nations to rethink their monetary systems. Others say the opposite, that only refined gold delivered to Earth will matter, and even then, the logistical costs will ensure gold remains precious. But perhaps the real shift will be emotional, not economic. If gold becomes common in the cosmos, its meaning may evolve. No longer a symbol of wealth or status, it might instead symbolize humanity's expansion into the universe. A gold ring forged from asteroid metal could become a symbol not of luxury, but of connection to our cosmic origins, a literal piece of the stars held in the hand. And yet, for all of gold's scientific and cosmic potentials, there is something deeply human that remains unchanged. Gold still fascinates us. It still comforts us. It still inspires us. Even in an age of digital currencies, quantum technologies, and artificial intelligence, gold remains the anchor people turn to in moments of uncertainty. When financial markets shudder, gold markets surge. When nations face instability, people buy gold. When investors lose faith in systems, they gain faith in gold. It is not logical. It is emotional. But emotion is the oldest currency in human history. This is why the future of gold is not simply technological. It is personal. Gold links us to our ancestors. It links us to the universe. It links us to the future we are building. In the coming decades, we will likely see gold used in ways that blur the boundaries between science and art, technology and philosophy, Earth and space. Quantum computers may use gold-based components. Advanced medical treatments may rely on gold nanostructures. Interstellar probes may shield themselves with gold. And perhaps, one day, when humans stand on Mars and look up at the night sky, at the cold, distant stars that forged gold billions of years ago, they will carry with them the same ancient metal that their ancestors once panned from rivers and hammered into crowns. Gold is not just a relic of our past. It is a guidepost for our future. It reminds us that human ambition is as old as the stars, that beauty can shape civilization, that the rarest things in the universe are often the ones that connect us most deeply to one another. And as we prepare to leave Earth, gold will go with us, not because we need it, but because it represents something timeless. It represents endurance. It represents identity. It represents the unbroken thread of human history stretching from ancient riverbeds to distant galaxies. Gold came from the stars, and one day we may return it to the stars. Gold has always been a symbol of ancient glory, a remnant of lost empires and forgotten kings. But in the 21st century, it has quietly transformed into something far more extraordinary. It has become the heartbeat of modern technology, the hidden engine behind the world's most advanced machines, and the silent partner of science as it pushes into realms once considered impossible. For thousands of years, humanity worshipped gold for its beauty, its permanence, and its power. Yet today, almost paradoxically, its greatest value lies not in crowns or coins, but in circuits, satellites, and microscopic particles that dance at the edge of the quantum world. This chapter is the story of gold reimagined, not as treasure, not as currency, but as the elemental foundation of a technological revolution that is shaping the future of human civilization. In the glowing screens we stare at each day, in the medical treatments that save lives, in the spacecraft that explore distant planets, gold is everywhere, working silently in the background. It never tarnishes, never corrodes, never fails under pressure, and in a world that depends on precision and reliability, those qualities make it irreplaceable. The world around you, your phone, your computer, your car, your hospital equipment, your data centers, runs not on electricity alone, but on gold. And somehow, most people never notice. To understand why gold became the metal of the modern age, you must understand the delicate fragility of technology. The devices we depend on are not simply metal boxes filled with magical components. They are incredibly sensitive systems, full of microscopic pathways that carry electrical signals so faint they can be disrupted by the slightest impurity. A single flawed connection can erase data, corrupt signals, or destroy an entire device. Copper, despite being an excellent conductor, oxidizes. Silver, the most conductive metal of all, tarnishes and corrodes. Aluminum is reactive, iron rusts. Even the best metals degrade with time, moisture, and air. But gold does not. This is the secret. Gold refuses to change. It remains pure, eternal, electrically perfect. That is why gold is used in connectors, switches, microchips, contacts, and every component where absolute reliability is required. Your smartphone has only a few milligrams of gold inside it, but those milligrams are the difference between a device that works for years and one that fails in a month. Every time you touch your screen or make a call, gold is helping transmit signals. Every time you open your laptop, gold is ensuring your circuits stay clean and uncorrupted. Every time a satellite sends data back to Earth, gold is protecting those signals across the cold, radiation-filled vacuum of space. Modern telecommunications as we know it, 5G towers, fiber backbone amplifiers, internet routers, depends heavily on gold-coated connectors and components that perform flawlessly under extreme heat and high-frequency oscillations. Engineers discovered long ago that when signals travel at the speed of light, even microscopic corrosion can cause catastrophic interference. Gold's stability is not merely beneficial, it is essential. And so, the same metal that once adorned pharaohs now carries billions of emails, financial transactions, video calls, and messages every single day. The world is woven together through golden threads so thin we cannot see them, but without them, the digital age would collapse. Even the global financial system, ironically, depends on gold in two ways. First, as a traditional reserve asset, and second, as the infrastructural backbone of high-frequency trading systems that require gold-based connectors to maintain near-zero latency. It is strange to think that gold, once used for coins and temples, now sits inside the most advanced data centers, ensuring the flow of information across the world. But gold's technological journey does not stop at electronics. It enters the frontier of quantum science. Quantum computers, the holy grail of next-generation computing, rely on components cooled to near absolute zero, where ordinary metals become unstable or superconduct in unpredictable ways. Gold, however, maintains structural integrity even under such extreme conditions. In many quantum systems, gold is used to fabricate the circuits that carry qubits, the basic units of quantum information. Researchers pattern gold films only nanometers thick to create delicate pathways where quantum states can be manipulated. At this scale, gold behaves differently than at the human scale. Its electrons interact with light, heat, and electromagnetic fields in ways that open the door to astonishing possibilities. Scientists have used gold nanoparticles to trap electrons, enhance optical signals, and even generate precise electromagnetic fields that guide the fragile dance of quantum particles. And as we edge closer to practical quantum computers, gold is steadily becoming one of the most valuable resources in the emerging quantum economy, not for ornamentation, but for computation that could one day redefine what is possible. Medicine, too, has embraced gold, perhaps more intimately than any other field. For decades, doctors believed gold's only medical use was in dental fillings, a practice dating back centuries. But modern research has transformed gold from a passive material into an active healing tool. In laboratories across the world, scientists are engineering gold nanoparticles so small that millions could rest on the tip of a single needle. These particles, when introduced into the human body, behave in ways no other substance can match. They can target cancer cells with extraordinary precision, delivering drugs directly where they are needed while sparing healthy tissue. They can generate heat when exposed to infrared light, destroying tumors from the inside, an emerging treatment known as photothermal therapy. They bind to biomarkers, enabling earlier and more accurate detection of diseases. They enhance imaging techniques, making it possible to see inside the body with clarity once thought impossible. In all these innovations, gold plays the same role it has always played. It remains pure, reliable, and stable, even in the chaotic environment of the human body. Unlike many metals, it is non-reactive and biocompatible, meaning it can enter the bloodstream without causing harm. This property alone makes gold a revolutionary material for future medicine. Yet gold's most profound role may lie beyond Earth, in the cold, unforgiving expanse of space. Spacecraft face a relentless assault of cosmic radiation, extreme temperature fluctuations, and intense ultraviolet light, conditions that degrade most materials rapidly. Gold, however, reflects radiation with exceptional efficiency, and its resistance to corrosion makes it ideal for space missions lasting years or even decades. NASA coats many spacecraft components with thin layers of gold to shield them from solar radiation. Astronauts' visors are lined with gold film to protect their eyes from the blinding glare of unfiltered sunlight. Satellites use gold-coated circuits to maintain precision even in orbit. The James Webb Space Telescope, Humanity's most advanced astronomical instrument, uses gold-coated mirrors to capture faint infrared signals from galaxies billions of light years away. In this sense, gold has become a bridge between humanity and the universe. It reflects not only light, but knowledge carried across astonishing distances, knowledge that rewrites our understanding of cosmic history. The same element forged in dying stars now helps us peer into the birth of new ones. Gold's relationship with space is more than symbolic, it is elemental. The universe itself created gold in moments of unimaginable violence. When neutron stars collided billions of years ago, they forged gold in explosions so intense they warped space-time. That same gold now coats the mirrors of telescopes that gaze into the ancient past. It is poetic to imagine that the material born from the death of stars is now used by humanity to study the origins of the cosmos. Scientists often speak of gold with a certain reverence because in many ways, it is the universe's memory. When we send spacecraft to explore other planets, we are not just pushing the boundaries of technology. We are honoring the journey of elements older than Earth itself. Gold becomes both the messenger and the message. It protects our instruments from the harshness of space, allowing them to survive long enough to send back discoveries that challenge everything we thought we knew. The Voyager spacecraft, now drifting beyond the solar system, carries gold-plated discs containing the sounds and images of Earth. These golden records are humanity's first interstellar communication, our attempt to speak across the stars, preserved in a material we trust to endure the eternity of space. In the cold vacuum where nothing decays, gold will remain intact, waiting for another civilization, or perhaps our distant descendants, to find it. In a strange and beautiful way, gold became the guardian of human memory. Back on Earth, gold is driving a revolution at scales so small they defy imagination. Nanotechnology, once a speculative field, has matured into one of the most promising sciences of the 21st century, and gold lies at its center. At the nanoscale, gold behaves less like a metal and more like a shape-shifting force of nature. Its optical, electrical, and chemical properties transform dramatically. Gold nanoparticles can absorb specific wavelengths of light, heat up instantly, or catalyze chemical reactions that were previously impossible. Scientists are engineering gold particles only a few atoms thick, constructing intricate frameworks that resemble architecture from a microscopic world. These structures interact with light and matter in ways that open the door to extraordinary possibilities. Imagine diagnostic devices the size of a single cell. Imagine medical treatments that target diseases without side effects. Imagine solar panels that use gold nanostructures to harvest light with near-perfect efficiency. Imagine sensors so sensitive they can detect a single molecule of toxin in water. These are no longer dreams. They are experiments happening now, in laboratories where gold is being sculpted by lasers, electric fields, and quantum forces into forms nature never intended, but science desperately needs. The rise of gold nanotechnology has also sparked breakthroughs in renewable energy. Traditional solar panels, while efficient, lose significant portions of light due to reflection and heat loss. Gold nanoparticles can enhance absorption, concentrating light into incredibly small hotspots that dramatically improve energy conversion. This effect, known as plasmonic resonance, allows gold to manipulate light at scales smaller than the wavelength of light itself. In theory, future solar panels could use gold to capture nearly all incoming energy, paving the way for devices far more efficient than anything built today. Researchers are even exploring gold-based catalysts for hydrogen production, a key element in the clean energy transition. Gold, once seen as chemically inert, has revealed an unexpected ability to accelerate reactions under the right conditions. It is ironic that the metal long considered the least reactive is now at the center of catalytic innovation. But this contradiction is exactly what makes gold so remarkable. It is a metal of surprises, a silent partner in discoveries waiting to reshape society. Yet gold's technological importance extends beyond science and engineering into the invisible world of global infrastructure. Modern aviation relies on gold-coated components for reliable avionics. High-precision sensors in aircraft, drones, and satellites depend on gold to maintain signal stability in extreme conditions. The global positioning system, the backbone of navigation for billions of people, requires synchronized atomic clocks inside satellites, many of which incorporate gold components to ensure that timing remains flawless. Without gold, your smartphone could not track your location, airplanes could not navigate safely, and logistics networks would collapse. Hospitals use gold-coated equipment to protect against malfunction during critical procedures. Laboratories rely on gold electrodes to ensure accuracy in chemical analysis. Even the financial system, ironically, depends on gold as both a physical reserve and a technological component. Trading terminals, supercomputers, and data lines all use gold to maintain flawless connectivity. It is a modern paradox that gold, once used to mint coins, now safeguards the digital economies that replaced them. But the rise of gold in technology has created a new challenge, one far less glamorous than ancient treasure or cosmic exploration. As devices become smaller, faster, and more powerful, the demand for gold quietly increases. Millions of smartphones, laptops, and smart devices are discarded each year, each containing tiny amounts of gold that often go unrecovered. This creates a growing problem: electronic waste. Landfills across the world are filled with discarded devices that contain gold worth billions of dollars. Extracting gold from this waste is possible, but it requires complex processes involving chemistry and high heat, and in many informal recycling sectors, those processes are dangerous. Workers in unregulated e-waste facilities in parts of Africa and Southeast Asia use crude methods, burning wires, melting components, applying toxic chemicals to recover gold. The environmental and human costs are staggering. Toxic fumes pollute the air. Heavy metals seep into soil and groundwater. The pursuit of gold in this context becomes a story not of progress but of exploitation. And yet even here, gold forces innovation. Engineers and environmental scientists are developing new recycling technologies that use bacteria, plant extracts, or bioengineered materials to recover gold safely and efficiently. These methods promise not only to reduce pollution, but to transform e-waste into a valuable resource. In the future, the gold for new devices may come not from mines deep in the earth, but from the discarded electronics of previous generations. Gold, in this sense, becomes a closed-loop material, eternal, recyclable, and sustainable. In parallel with recycling innovations, researchers are exploring gold alternatives for certain applications, but the results are mixed. Palladium, platinum, copper, and advanced graphene-based materials offer potential replacements, yet none match gold's perfect combination of stability, conductivity, malleability, and resistance to corrosion. Engineers can substitute gold in limited situations, but at the highest levels of precision, spacecraft, medical implants, quantum devices, there is no replacement. Gold remains the metal of last resort, the standard of reliability when failure is not an option. And this truth carries profound implications for the future. As technology becomes more integrated into daily life, from autonomous vehicles to wearable health sensors to neural implants, the need for materials that never degrade will only grow. Gold's role will expand, quietly but inevitably, as humanity steps into a world where machines and biology begin to merge. In the realm of biotechnology, gold is becoming something even more astonishing, a bridge between human biology and engineered intelligence. Scientists are experimenting with gold-coated neural electrodes so thin and flexible they can interface with the brain without causing damage. These electrodes can detect signals from individual neurons, translating the electrical language of thought into digital information. Imagine prosthetic limbs that respond to the brain as naturally as biological ones. Imagine memory implants that help restore lost cognitive function. Imagine treatments for neurological disorders that can precisely target misfiring neurons. At the core of these possibilities is gold, whose conductivity and biocompatibility make it uniquely suited to the delicate task of interfacing with the human nervous system. Researchers at leading laboratories have created gold nanowires so thin they can slip between cells without triggering the immune system. These wires can transmit signals with incredible fidelity, offering a future where technology does not replace the human body, but enhances it. The line between biology and machine grows thinner with each passing year, and gold, ancient, immutable gold, becomes the silent material enabling this transformation. It is almost poetic that the metal once used to crown kings may one day help restore sight, hearing, or mobility to millions of people. This convergence of gold and biotechnology extends beyond the nervous system. Scientists are exploring gold nanoparticles for gene delivery, where the particles carry strands of DNA into cells, enabling targeted genetic modification. Traditional gene therapy struggles with issues of stability, toxicity, and immune response, but gold's inert nature makes it an ideal carrier. In experiments, gold nanoparticles have successfully delivered genetic material to cells that resist traditional methods, opening the door to treatments for diseases once considered incurable. Researchers are even using gold to mimic enzymes, creating artificial catalysts that perform biological functions inside the body. These nanoenzymes can break down harmful molecules, reduce oxidative stress, or trigger chemical reactions at precise locations. It is a realm where biology, chemistry, and physics converge, where gold becomes not just a substance, but an active participant in life itself. And as these advances progress from laboratory to clinic, gold may quietly become one of the most important medical materials of the century. Even agriculture, perhaps the last place one would expect to find gold, is beginning to embrace it. Nanoparticles of gold are being used to enhance plant growth, improve nutrient absorption, and increase tolerance to environmental stress. Early studies show that gold nanoparticles can stimulate photosynthesis, allowing plants to convert sunlight more efficiently. This is not science fiction. It is experimental technology with real-world implications, especially as climate change places unprecedented strain on food systems worldwide. If even a fraction of agricultural output can be improved through nanotechnology, gold may help sustain billions of lives in the decades to come. The idea seems surreal. A metal associated with wealth, luxury, and opulence becoming a tool for global food security. Yet this is the future unfolding before us, a future where gold's value is measured not in currency, but in survival. Gold's expanding role in technology is reshaping geopolitics as well. For most of human history, gold influenced the rise and fall of empires through finance, trade, and conquest. Today, its influence is shifting toward control of global supply chains, technological infrastructure, and advanced manufacturing. Nations with significant technological industries, Japan, South Korea, the United States, China, Germany, depend heavily on gold for semiconductor production. As smartphones, electric vehicles, medical devices, and artificial intelligence systems multiply across the globe, the need for gold quietly intensifies. This creates a new form of competition. Countries secure gold not only as a financial reserve, but as a strategic resource for technological dominance. A shortage of gold could halt semiconductor fabrication, disrupt telecommunications, or cripple aerospace manufacturing. In this era, gold has become a subtle but essential pillar of national security. Just as oil powered the industrial age, gold may become one of the foundational materials of the digital age. And then, there is the emerging frontier of asteroid mining. For decades, it existed only in the pages of science fiction. But today, private companies and national space agencies are developing the technology to extract metals, including gold, from asteroids that orbit near Earth. These asteroids contain quantities of precious metals far exceeding anything available on the planet's surface. If even a single metal-rich asteroid were fully mined, it could theoretically flood global markets with gold and platinum. But in reality, the economics are more complex. The true value may lie not in returning gold to Earth, but in using it directly in space. Over time, humanity may establish industrial systems beyond Earth's gravity, manufacturing satellites, spacecraft, and scientific instruments in orbit. Gold, with its exceptional resistance to radiation and corrosion, would be essential in building these off-world technologies. The idea that gold may one day flow through factories floating above Earth is both astonishing and logical. It reflects the same pattern repeated throughout history. Gold evolves with us. It adapts to our needs, our ambitions, our imagination. But this future raises ethical questions. Who owns space resources? Who controls the technology? Who benefits? In the past, gold rushes have led to exploitation, inequality, and conflict. If humanity is to extract gold from the heavens, it must do so with far more wisdom than it showed on earth. Yet despite these concerns, one truth stands out. Gold will shape the future just as it shaped the past. As long as humans pursue innovation, gold will be there, at the core of circuits, floating in nanostructures, coding spacecraft, healing bodies, transmitting data, and carrying the weight of both ancient history and cosmic origin. Still, even with all this technological progress, gold's essence remains unchanged.